Okay, here is lesson 111 on those blue half sheet warm-ups. So the first one is asking about these two clocks up in the corner, clock A and clock B. It says how much time has passed between clock A and clock B. The B gets stuck way over there. So I think the first thing we need to know is what time do these clocks say? And I know some of you like digital clocks and not these analog clocks. So if this clock was numbered, this would be a 12, and it would say 1, 2, 3, 4, 5, and so on. So we can tell the shorter hour hand is a little bit past the 4. So we know this clock says 4 something. And then we do minutes starting up at the 12. We've got 5, 10, 15, 20, 25, 31. So this clock says 4:31. The other clock, 1, 2, 3, 1, 2, 3, 4, 5. We're a little bit past 5. This clock says 5. And counting by 5s, we've got 5, 10, 15, 20, 25. So 5:25. So how much time has passed from the 4:31 to the 5:25? So basically, I am just wondering how many minutes it took this hand to go all the way around and be pointing at this 25, like it is over here. So I know that from 31 to 35, there's 4 minutes. I think I'm going to keep that 4 minutes in mind and then just count by 5s because that's going to be easier. So we've got 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, plus these 4. So it looks to me like 54 minutes. 54 minutes. All right, next we are ordering the decimals and fractions from greatest to least. So we've got all these 6s and 7s here, and I think to make this easier, I'm going to write these all as fractions. So 6.7 is 6 7/10, or 6 7/10. I think I'll zoom this in a little bit. And 6 6/10. We'll leave 6 6/7, so that's already a fraction. Now this 66/7, it's helpful to change this back to a mixed number. So how many 7s are there in 66? It seems like there are 9. I've got 3 left over. So this 66/7 is actually equal to 9 and 3 7s. Which now that makes it really easy to see what the greatest one is. The greatest, I'll write that over here, is 9 and 3 7/7. So we got that taken care of. Now next we've got 6 6/10, 6 7/10. We know 6 6/10 is less than 6 7/10. The question is about this 6 6/7. When we were estimating fractions, we noticed that 6/7 is almost 7/7, so it's close to 1. So if we are estimating, we are thinking that this is closer to 7 than 7/10 or 6/10, because these are just a little bit past a half. So our next greatest is 6 6/7. Then 6 7/10, and finally 6 6/10. Okay, number 3, complete the subtraction algorithm. This word algorithm just means process or rules. So we need to just subtract we have 1,035,410. And we are taking away some number to equal 542,306. So let's start over here in the ones place. We have 0 minus something is 6. We can't take anything away from 0 to get 6, so we are going to have to do some regrouping. We'll make this be a 0 and this may be a 10. 10 minus 4 is 6. Okay, 0 minus 0 is 0, 4 minus 1 is 3, 5 minus 3 is 2, 3 minus 9 is not 4. We're going to have to do some more regrouping. We cannot take anything from this 0, so we're going to go all the way over here and make this a 0. Make this be a 10. Now we can borrow from the 10. That'll become a 9. This can be 13. Now 13 minus 9 is 4, and 9 minus 4 is 5. Okay, now we are completing the matching table for each statement. So we are saying if these are true or false. So 1 million is 1,000 times larger than 100. So we're talking about 100 and 1,000 times greater, and we want to know if that comes out to be a million. So let's go ahead and multiply this. I know 1 times 1 is 1, and I know I can just place these zeros when I multiply. So I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that ends up being 100,000, not a million. A million has 6 zeros. So this one must be false. Our next one here says 100,000 is 10 times smaller than a million, which means that a million is 10 times greater than 100,000. So let's see if I can squeeze this in over on the side. So 10 times 100,000. Let's see what that equals. Again, 1 times 1 is 1. And I'm going to place those zeros. 1, 2, 3, 4, 5, 6. I need 6 zeros. 3, 4, 5, 6. And that is a million. So it looks like 100,000 is 10 times less than a million. So we'll say true. And this last one, 10 times 10 does equal 100. And is 100 100 times larger than 1? Let me see, 100 times 1 is 100. So it does seem like 10 times 10 is 100, which is 100 times greater than 1. So we're thinking this one is also true. Last one, number 5, with these angles. So the measure of angle, this little guy here means angle. Angle KMP. So that's KMP is 100 degrees. So what we're saying here is that if you were standing at M and looking at K, and then you spun around to look at P, that's 100 degrees. So you would have turned 100 degrees. And then you keep on spinning to look at L is another 130 degrees. And they want to know if you complete the spin, how many degrees is that little turn? So the thing we have to remember here is that if you are facing a certain direction and you spin all the way around to face that direction again, that's 360 degrees. So a full circle is always 360 degrees. And we have so far gone 100 degrees. We've gone 130 degrees, which is a total of 230 degrees. So how much farther to get to 360? So let's see, I'll do 360 and take away that 230. I get 130. So it seems like 130 more degrees gets us to 360 degrees. So the measure of KML is 130 degrees. 130 degrees. All right, thanks for watching this. Make sure you do one of these sheets every day.